Hello, hello, welcome back. We're going to do day two of arcs and sectors. We learned last week on how to find the area of an arc length, which we took our arc measure, divided by 360, and then we compared that to our circumference, or our arc length here, divided it by our circumference. So we had kind of part, whole, part, whole. If we multiply both sides here by our circumference, like this, we can also just use our arc length equal our A over 360 times our circumference. So that's another way you can do this. So this is kind of this one right here is kind of using proportions method. This is kind of more of a formula method if you didn't want to set up the proportions and then cross multiply. So you can just say our arc length is that fraction of my my arc measure multiplied by my circumference. And the reason I'm showing that to you today is because now we're going to get into a little bit of a more with talking about the area of a sector of a circle. And it gets a little bit easier to do when you use the formula, okay? So a sector of a circle is a region bounded by two radii and an intercepted arc. It's kind of like this little piece of a pie area in here, okay? And we find that the same way we'd find arc length, right? This is a portion of the area of a circle, just like arc length was a portion of our circumference. This area of this piece of pie is a portion of our area. So we find that the same way. We'd say, that's going to be 90 over 360. And that's going to be equal to our area of our sector. I'm just going to call it area of my sector here, over my area of my circle. Okay, so again, part to whole, part to whole. And again, once again, if I just take my area of my circle, which, by the way, I'm just going to go ahead and back up here for just a second. Instead of writing area of my circle, I can write actually just pi r squared, right? So pi r squared. So now if I want to multiply both sides by pi r squared, then I just know that my area of my sector, you know what that means, is 90 over 360 times my pi r squared. Okay, so we just take that fraction of the circle, so 90 divided by 360 times pi r squared. Okay, over here we just do the same thing. We'd say, okay, what is the area of this? This is basically a circle, right? If we were to continue on around. So don't let that, freak you out if you just see like a piece of pizza. It's still going to be my area of my sector. It's still going to equal my portion of my arc measure, so 60 over 360, times my whole area, okay? Pi r squared. So in this case, it'll be pi times 4 squared, okay? And so that's my formula for my sector of a circle. Okay, so we're going to use that. So I'm going to write over here my formula. So my area of a sector is going to be equal to my arc measure divided by 360 times pi r squared. Okay, and so you might want to write this down somewhere. Make sure you have that handy. Okay, so let's find the area of this sector M and Q. So there's M and Q is this what's bound in this region right here, right? So we're going to take our area of our sector is going to equal to 78 over 360 times my pi r squared. Pi times 10 squared. Okay, 78, if I divide 78 by 6, let's take this right here. I go 78 divided by 6, that's going to equal 13. So I have 13 divided by, and then 360 divided by 6 is equal to 60. So it's 13 over 60 times 100 pi. Okay, well, 10 will go into 60 6 times, and 10 goes in 100 times. So we end up with this 130 over 6 pi. So this is if you remember, this is my exact answer, right? And if I want to get an approximate answer, then I would take 130 divided by 6, and I would multiply that by my pi. Oops, not h, by my pi. Go backwards here, pi. There we go. It'd be about 68.1. So my area of my sector would be approximately 68.1. Okay, depending on if they ask you for an exact answer or an approximation. Okay. Okay, so you might want to try this one. Just pause the computer for a moment and try this problem here and see how you do. Okay, so here we have my area of my sector is going to be my fraction again. So my 165 over 360 times my pi r squared. So pi times 3 squared. Okay. My 165, I'm just going to divide this by 5 and see what happens here. So go 165 divided by 5, not times 5, 165 divided by 5. And I get 33, and 33 is just 3 times 11, so it's not going to be divisible anymore, I don't believe. So we're going to get 33 divided by, and then 360 divided by 5 is 72. And I think I can divide that further by 3. So this will become 11. And then 72 divided by 3 is 4. Oh, not 72. 72. Oh, come on. 72 divided by 3 is 24. And that's as far as I can simplify. And that'll become times 9 pi. Okay. And then 3 will go into 9 3 times, and 3 will go into 24 8 times. So we end up with this 33 over 8 pi. And that will be my exact answer, right? If I want to simplify or multiply that out and get an approximation, I would have my 33 divided by 8, and then multiply that by pi. So times my pi, and that gives me about 12 point. We can call that 13.0. Okay, so about 13.0 for this guy. So that's both my exact answers and my approximation. All right. Okay, moving on here, we're going to move on to an area of a segment, it's called. So it's like this little piece that's between a triangle and the edge of a circle. So it's kind of like your thumbnail, I guess. Okay. And so what we need to do is we need to take the area of the sector, the little pizza piece we've been finding already, take that whole area of the whole pizza piece and subtract this area of the triangle. And that will leave us with that little thumbnail piece at the end. Okay. And so we're going to go ahead and try to find this area, this sector right now. So we're going to take our area equals our n over 360. So 60 over 360 minus pi r squared. In this case, it's 8 squared. Okay. And we're going to go ahead and actually calculate this the whole way because we're going to have to combine these two. So we're going to have to go ahead and go 60 divided by 360. And we're going to multiply that by 64 pi. Gracious. Not subtract right here. It's multiply. Wise. There we go. So 60 over 360 divided by 360. And we're going to multiply by 64. And then multiply by pi. Okay, so we have 33.5 approximately. So 33.5, that's my area of my sector. Okay, and we're going to subtract our area of a triangle. Now this is a little tricky because this is 8 down here, which means if I draw an altitude, this would be 4. Okay, and if you remember our special right triangles, because that's an isosceles triangle. So if I do that, that's going to be 4 square root of 3. If you go back to my special right triangle properties, this is a 60, 60, 60, which means this is going to be a 60, 30, 90. Okay, so if this is 4, this height is 4 square root of 3. So therefore, my area of my triangle here is going to be area equals 1/2 times my base, which is 8, times my height, which is 4 square root of 3. Okay, so we need to multiply all of those. So this is going to become 4, 1/2 of times 8 is 4, times 4 square root of 3, which is 16 square root of 3. Okay, so let's multiply that there. We're going to get, let's go on 16 times, and then my square root of 3. That's about 27.7. So we're going to 27.7. Okay, so we're going to take our 33.5 and subtract 27.7. That's my area of my triangle. So about 5.8. Okay, so my area is going to be equal to about 5.8, and that's the area of my segment. Okay, it's the area of my little segment. And I should have put that in green actually. That's the area of my segment there. Okay, And so that's when we'll find the area of our triangle, find the area of my sector, take the sector and subtract my triangle. Okay, so let's go ahead and come over here and you guys can try this on your own and let me know how you do. Okay, so first of all, let's take our area of our sector. Okay, area of our sector, and that's going to be 90 over 360, which is 1/4, right? 90 over 360 times pi r squared. Okay, so that area of that sector is going to be 90 over 360, 90 divided by 360, and then times 100 because it's 10 squared, times pi. Okay, so 78.5 approximately. 78.5 is the area of my sector. Okay, let's look at the area of my triangle. Area of my triangle is 1/2 base times height. Now, in this case, it's a right triangle, so I know my base. If this is 10 right here and this is 10, that is my base and height because they're perpendicular. So it's just going to be 1/2 times 10 times 10, because this is 10 and that's 10 and they're already perpendicular. So that is my base and height. It's kind of nice. Okay, so that becomes 1/2 times 100, which becomes 50. Okay, so if you recall, my area of my segment is going to be equal to 78.5, which is my whole piece of pizza, minus my area of my triangle, 50. Okay, so my area of my segment is going to be equal to 28.5. Okay, that's the area of my segment. All right, and that is how you find the area of a segment. Okay, Chen uses circular cork boards to make 18 watermelon coasters, like you see right here, to sell at a craft fair. He paints one side of each coaster with special paint. Each jar of paint covers 200 inches squared. Will one jar of paint be enough to paint all of the coasters? So we're going to find out what's the area of one, and then multiply that by 18 to figure out how many square inches we have, and then see if that's enough. Okay, so that, first of all, let's just find the area of one of our watermelons. Okay, so the area of one watermelon is going to be 72 over 360 times pi, and we need a radius. And since he uses this cork board here, this is 4, is going to be my radius. So that's going to be pi r squared. That's my radius. Okay, so let's calculate that. We can just take this all in one fell swoop here. So, and by the way, in your homework, I want to see you set up the area first, just like this. Okay, then if you want to use your calculator and multiply it from there, I'm okay with that. Okay, so 72 divided by 360, that equals that, 1/5. So then we have times pi and times 16. That's going to give us about 10.1. Okay, so the area of 1 is about 10.1. Well, then we need to multiply by 18, right? So the area of all 18 of them, area of all 18 is going to be equal to, multiply this times 18, 180, and I'm going to call it 181.0. Okay, 181.0, and that's going to be inches cubed, or inches squared, excuse me. Well, each jar covers 200 inches squared, so yes, we're going to have enough paint to cover those. Okay, now let's go to this next page here, and this time they're going to ask us, he's going to put decorative taper on the edge of each coaster. So how much tape does he need for that? So now if we're talking about putting taper on the edge, we're talking now about circumference, right? Arc length. So now we need to calculate the arc length. So now we're going to talk about my arc length is going to be equal to 72 over 360 times my circumference. So this time it's going to be pi times my diameter, 8. So my diameter is 8 there. Okay, so now let's calculate that, guys. So we're going to have 72 divided by 360. Oops, 360. And that's 0.2 again, and then times pi times 8. So my circumference of one of these little pieces is going to be, whoops, I didn't catch that, 5.0, basically. My arc length is going to be 5.0 approximately. And again, I need to multiply that by 18, right? So my arc length, all my total, the ones that I need are going to be 18 times 5, which is going to be about 90.5. 90.5 inches is what he'll need to cover, make sure he has all of the edges covered for all of his little watermelons. Okay? So, make sure you keep difference between the area versus my length, which is my circumference around. Okay? Okay, so what is the area and perimeter of sector QNR? Okay, so we want our area. So first of all, we need the actual, what is the measure here, right? Well, if this measure out here is 260, then here must be 100, right? 100, because 360 minus 260 is 100. Okay, so if I want to find my area of my sector, it's going to be 100 over 360 times pi r squared. Okay, so if I divide those by 10, I get 10 over 36. And then 2 goes into 10 5 times, and 2 goes into 36 18 times. So I'm going to be left with 5 over 18 pi times 36. Well, 18 goes into 36 twice, right? So this is going to be just 10 pi. So that's my area of my sector of that guy. Okay, now let's find the perimeter. That means arc length, right? So it's my arc length is going to be, again, my, we know that this is already 5/18 because we've already reduced that down. So I'm just going to go ahead and put 5/18. 5/18 times my circumference, which is going to be 2 times pi times r, 6, since we're given radius. So that's going to be 5/18 times 12 pi. And this time, 6 goes into 12 twice, and 6 goes into 18 3 times. So that's going to be 10 pi over 3, right? Well, that's just my arc length right here, right? But the perimeter of this entire thing also includes this 2 right there. That 6 is that 6. So my perimeter of Q and R is going to be equal to 10 pi over 3 plus 2 times 6, because we have to add, 2 times 6. We have to add those other 2 6s around. So let's go ahead and just calculate that out, because we need to actually find what the perimeter is. So we're going to go 10 divided by 3. We're going to multiply that. Oh, shoot, let's see. I'll have to start over. 10 divided by 3. And then we're going to multiply that by pi. Okay. Then we're going to add 12, because 2 times 6 is 12. And we get 22, about 22.5. Okay. 22.5, I should put approximately right there, is my perimeter of Q and R. Okay. That's just a little application for you. Okay, so here's all of your summary. Okay, so here is my arc length, where my arc length, it goes n over 360 times 2 pi r. Here is my area, same thing, n over 60 times area, pi r squared. So the only difference here is what formula I'm using to multiply by that fraction. And then my segment area equals my sector area, which is up here, minus my triangle area. Okay, and then that is it. And you have an Excel in Google Classroom. And please come to the classroom with any questions you have, and I will see you guys soon. Thanks very much. Bye-bye.